I prepared this talk quite a while ago for Bitcoin Pizza Day and couldn't give it there, unfortunately. So now I'm a little bit intimidated because of the crowd here that I have in front of me. Because back then, I kind of just wanted to chill next to them, to make them all use it. And now we had such great content already, and you're basically all already Nix-pilled, I guess. So I will still give it a shot, and I think I have a few interesting bits here and there where someone might learn something new. But if not, it's at least an example of how Nix can really make a project work so much better. I will be mostly talking about how the Fedimint project uses Nix and NixOS to be more effective, to make developer life easier. Yeah, and so let's get started. Nix as a Cypherpunk tool. I think the most well-known quote about cypherpunks is that cypherpunks write code. So that will be a huge part of this presentation today. But I also wanted to extend this, and because only writing code isn't getting us anywhere. We are not living in the cypherpunk future if we're only writing code. We also need to compile it, and then we need to deploy it. So we'll be talking about these three things today. How Nix helps us write, compile, and deploy code. First to the writing. That's where you come in. Developers, 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 developers. And to retain and to attract developers, it's a really crucial thing for open source projects because there aren't that many of us, and especially not that many that are willing to spend their free time coding, hacking on open source software that doesn't give them back anything directly. It's a purely ideological thing. So we cannot waste this resource. It's one of the scarcest things we have. So one of the big goals of Fedimint is to make developer life as easy as possible when onboarding. And so what we don't want to do is this. You have a whole document where you need to install a bunch of dependencies, then it might change your system. Now other things might fail because of that. And it's just really intimidating. If you have ever tried to install Bitcoin Core from source, it's really not that easy. Now you're compiling some database from source because you need the right version, all this kind of stuff. When you compare it to how easy it can be with Nix, you might not see it right now, but it's literally only this one command you need to get started with developing Fedimint. It's Nix develop, and there you are. We're also using a very nice little tool called Just, which is essentially an updated version of Make. You might know the author. He came to fame recently with ordinals and inscriptions. It's also built by Casey. It's a really useful tool. In my opinion, a little bit more useful than ordinals, but opinions might differ on that one. Yeah, so basically you need one command to get into a developer environment, and then you have all the tools that all the developers that came before you built for this project at your disposal. You see a few of them here. You can just build a project. You can run checks and linters, all this kind of stuff. Then another thing that's often hard to achieve for open source projects is that the tests that run in CI, in continuous integration, you might want to run them locally because you have a really nasty bug that you want to find, and you cannot, when it's only running in the cloud somewhere on GitHub Actions, it's not easy to introspect what's actually happening. You don't have all the tools you have at your disposal locally. So what we can do with Nix actually is we can specify our whole CI toolchain or our whole CI in Nix, and then only what GitHub Action runs is the same as I could run locally. It's all encapsulated in the Nix build system. And for example, when you want to run all the CI tests for Fedimint, you just call Nix build. If you want the logs, then -big L and #CI.test.all. That's all you have to do. And I was actually lying when I said running it locally, because now you also have something really, really cool with Nix. You might not have the best machine for running tests at your hands right now, but you might have a big server in the cloud somewhere, but where you can log in, so you can attach a debugger and stuff like that. And Nix actually allows you to, with like these two further commands, say, okay, I kind of want to build this package, like the CI test package, but please do it on this machine there. And that machine might have like 64 cores and a lot of RAM, so it's going a lot faster. So that's all kind of, like all these are like little things that make developer life day to day so much more enjoyable. Then also, like you might not be only building like one application. Like for example, in the case of Fediment, we have our Fediment daemon, which is the server-side software, but we also built a Fediment client library, which can be used by end-user applications, like for example the Fedi app, or Webiment, which is the open source version that I'm building, to build client applications. And you don't want to reinvent the wheel. Like for example, for Webiment, I'm using nearly exactly the same developer environment as Fediment by just importing it as like a flake input and just adding a very few, where is it? A few packages down here, like that are needed in addition to what Fediment already needs. And I'm good to go. Like that's the whole developer environment for Webiment. And like the biggest chunk, like over 1,000 lines of Nix, is still maintained by the Fediment open source project. And this, my little weekend project, yeah, it doesn't have to worry about that. So, like the biggest part here, providing code, it makes onboarding new developers very, very easy. Like you cannot have dependency conflicts between projects. Like especially in the Python world, it can be rather annoying if you have like two projects using different versions of the same package, and then you need to decide what to install. And I know there are like all kind of workarounds for that, but Nix is so much cleaner. Then you kind of get the same instructions for all the platforms. Like earlier, I think I only showed for how to get set up with Bitcoin, for compiling Bitcoin. I only showed the Ubuntu and Debian instructions, but then there's like Fedora-based operating systems, like Arch-based operating systems. Like all of them would have slightly different instructions that you need to maintain as like an open source project. And that's a lot of work. So with Nix can be installed on all of these different operating systems, even on Mac. Even so, there are some kinks there. And if you maintain like this one description of how to build and develop your project, then you cover them all. And yeah, lastly, you can also run the CI locally. I showed that. It does push a lot of complexity to the existing contributors of the project. That's something we experienced, but fortunately, we have some really OG Nix people on our team now, and they did some great work. I will be shilling like one of their projects at the end, which is basically the blueprint for what we're doing with Fediment. And it assumes an existing Nix setup, which isn't a given. But the good thing about that is there's great documentation on how to set up like a really basic Nix environment. Like generally documentation in Nix isn't all that great, but for getting started, I think it's really good by now. Yeah, and I think that concludes the writing code part. But what about compiling? Like it's probably something that we spend a lot of time on. Like there is this XKCD for a reason. Like why are you slacking off again? I'm compiling my code. And so what is interesting about compiling? Like first of all, we talked about this already today, is not everyone wants to compile your software from source. It takes a long time. Like for example, if I compile Fediment from source on like a 8-core machine, it still takes like 5 to 7 minutes, I think, and I didn't time it recently. Like we sometimes make some improvements there, but it takes a long time. And if you do this for a lot of software, it becomes really annoying. So what you want is reproducibility, so that someone can build the software for you. You can verify if you want to, and ideally you can find other people that already verified that for you, but then you can just use that artifact. And I think there was a great talk about TrustX this morning, which uses exactly that concept. Like multiple people build the same binary, and if you get the same outcome, then I mean maybe you don't need to build it yourself anymore. You just use what there's agreement on and consensus on. Actually, if you want to try this out, I'm not entirely sure if we're 100% reproducible. Like for x86, I got these hashes. Maybe try it out. It's the release version 0.1.1 from Fedimint. Yeah, if you have hashes for me, tell them. Okay, another interesting thing about compiling is not all our end users are Nix. Like we might be able to convince all our developers to install Nix, but end users is a different topic. And so it's quite interesting that Nix lets you, without building a totally separate build instruction set, lets you generate Debian and RPM installation files. So you can now also use your same build instructions for targeting Debian and Fedora-based systems. And also, of course, like just building raw binaries. It's a little bit finicky at times, because what Nix is doing internally is essentially it packs up all the dependency it needs into like one binary, and at runtime it unpacks them. And it's not the nicest thing to do, I guess, but it works. So just because you're using Nix in your build pipeline doesn't mean your end users have to use Nix. And yeah, like for example, in our Fedimint CI, every time we push the master, we build these packages, and it's actually not that complicated. Like you can see, there is a flake for that, or like it's called a bundler. I don't know the exact intrinsics of it, but you basically tell Nix to use a specific bundler and then build a specific flake output, and it will generate a Debian or RPM file for you. So from an end user's perspective, it's quite simple if you don't run into any problems, which we sometimes do, but in the grand scheme, it's relatively straightforward to do. Then last but not least, cross-compiling is another issue, and at least from my perspective, Nix makes it much easier because you don't have to install, like again, the cross-compilation toolchain globally, but rather whenever I want to do anything related to cross-compiling, I either go into a specific dev shell that's made for that, or I already have endpoints set up or flake output set up that do the cross-compiling for me. And that works quite well for us. Like it's also about reusability again. Like for example, if you're building a WASM blob in your CI already, then other people integrating with it don't have to do it. They just take that, or they can import like that flake output and use it for their applications they're building, which is quite convenient. Then the last part is the one that actually kind of inspired me for the talk title. Like why Nix could be considered a cypherpunk tool. Because originally the title was kind of like to get into Parallelipolis and Nix pill all these cypherpunks. So, but there's actually some truth to that. Because as cypherpunks, we write code, yes. But if you have read the Cypherpunk manifesto, then in the same paragraph, it mentions something quite crucial. We don't care if you don't approve of the software we write. We know that software can't be destroyed, and that widely dispersed systems can't be shut down. Like that's exactly the way Bitcoin works. But it also encodes a different message. We are in conflict with an existing system, and as such, like we might be building open source code because there, like everything is public, we can verify everything. But for example, if you're running an operation, like something where you do have operational secrets, then third parties become security holes. And since we are in conflict with an existing system, we cannot easily do what companies typically do. Companies just hire people that are experts in the specific fields. But if you're running something that the existing system doesn't agree with, then every single person you add to your operation becomes a security hole, a potential one. So what we need to do to be effective still, we need to empower the individual to have like all the knowledge of all these experts at its disposal. And I think that's where Nix can really shine. Like, it doesn't do it everywhere yet, but it's a vision for the future, for what to build. One example where it already works really well, in my opinion, is, like, I remember setting up Nginx servers with certbot so I can get certificates from Let's Encrypt many times. It's very annoying. You're fiddling around with Nginx configs. You're setting up systemd services to keep like your certificates updated, and it requires a lot of intricate knowledge of like configuration file formats, of how these systems work, and it just takes away mindshare that you could use for other things normally. With Nix, it's quite easy. Like, you see a service that I set up without SSL, and now it's with SSL. It's 2 lines, not more. So it's just one example, but it's, I think, a really powerful one. Like, if you never thought about how does certificate issuing work, how does configuring a web server work, then with this simple small template of Nix, you can get a web server that's secure with good defaults, with everything, because experts built this Nix module, which you can now easily reuse. And if we do the same for like all the relevant software, like we already have a great repository with Nix Bitcoin for the Bitcoin ecosystem, which comes with awesome security defaults, like with all the network namespacing and like what everyone should do, but nobody has time to learn this stuff. So that's why we need a language or a system like Nix that can encode this expert knowledge, where like a few like gigabrains, like Jonas, like Eric Warstead, like sat down and built this amazing secure infrastructure, and now we as mere mortals can use it. And so everyone has their own like expert field. Like, for example, if I build a Fediment module, then it's much easier for me to do that than anyone else probably in this room. But then I can share it in a like reusable manner, which isn't possible, in my opinion, in any other way right now. Like, I've seen people share Ansible playbooks, but even there you're fiddling around, you're changing stuff. It's not easy to like give back. For example, if someone finds a problem with how Nix Bitcoin does stuff, then they can open PR, easily fix it. If someone publishes a random Ansible playbook and someone pulls it in, then it's not as easy to give back to them, at least in my experience with working with different kind of systems for systems management. It's quite unique to Nix. Another interesting feature that I use quite extensively, maybe because I'm working on weird software like Fediment, where you always have to deploy, like, for example, 4 instances of the same thing just to test out if it actually works. Because, like, if you're setting up a federation, then, and it's a 3 out of 4 federation, you need 4 Guardian servers to test if, like, for example, your setup procedures work. And the cool thing about Nix is it's a functional language. So instead of building a specific system description, what I'm doing here in this example is I build a function called demo, which takes as input a host name, a hashed password, and an IP address, and then builds a whole system configuration, which is later deployed with Colmena, even though Carl mentioned it's probably not the best way to go about it. I might change that, but it works. And like, instead of writing 4 system configurations and then copy-pasting different values in, I just have a function that generates these, and I give them the inputs it needs. And also related to like the previous point of sharing expert knowledge, I think I got these slides in the wrong order, is feature discoverability. Because now we have a formal description of configuration options. Like we don't have to learn 1,000 different arcane configuration file languages anymore. We have one, and it's easily discoverable. I think there's even a way to search for flake options, like for example, in Nix Bitcoin, which aren't in the official modules repository. But if you're looking for any service that you're trying to run, and you're not sure how you can configure it, then just taking a look at the official NixOS website and the options search will give you a great overview typically. And I think that's also quite important because you might not know all the options that exist for your software that you're trying to run. The last point that I actually want, I'm actually using and I want to make is that you're getting infrastructure as code here. Like when I'm deploying my services that I run, for example, recently like some forwarding broke and people couldn't join our Discord anymore, so I set up my own forwarding service. It's only a bit of code that I push and that someone in theory could review. And that's actually pretty cool. And we'll get to that in a moment. Because if we have infrastructure or like services that we run as code, then we can suddenly have teams of admins basically that where no single admin can take over the entire system anymore. Like instead what we can do is all of them review the changes we want to make to our deployed system and approve them. I actually heard a very interesting, a similar idea years ago by Jonathan Logan, aka Smuggler, who is like in the Cypherpunk community around Paralinipolis. He's active there and also in Berlin. But he had the idea, and I'm not sure if it was ever implemented, that for managing systems, you would have a mirrored SSH session. And like every time one of the admins enters a command, then the other one has to acknowledge it and approve it. But if we can get away from this instruction-based management of our systems and move to one that's more descriptive, then I think just having a typical GitHub review process or general like self-hosted Git review process is so much more powerful. Because you can also just try out the changes locally, like Jonas showed with Nix Bitcoin. Like just run the entire setup or the entire Nix Bitcoin instance locally and test if all your continuous integration tests still work. Also, if you're working in a hostile environment, you might need to switch servers quite often. Like I read in like a description for how to run hidden services long term that you should be switching your servers quite often if you're getting a lot of incoming traffic because Tor isn't that secure anymore. And if you're a well-frequented site for reasons that we don't want to go into any further, then you're probably switching servers quite often and it's quite a hassle. And with Nix it can be so easy. Like you just upload your flake.nix, call Nix rebuild switch, and there you go. You have a new server with exactly the same configuration, maybe migrating some state. And yeah, if we take this to an extreme, then maybe eventually we can get to a state where we have a service that notices, okay, I have like 10 instances of myself running. One of them just got taken down. Hey, I just spawned a new one. If we get parametric and electronically payable, like for example via Lightning, hosting solutions, then we could build software that self-deploys, self-replicates, and is basically a living organism. And maybe even rewrites itself if we get far along with LLMs. And if LLMs understand Nix code, which I hope they will do eventually, then we could have software that just lives. And I think it would be a beautiful thing. You might be thinking, okay, that's already possible. And I would agree. We can kind of do a lot of that stuff with existing solutions like Ansible, but come on, why not do it right this time around? Like, say no to Ansible. and someone please make a sticker. I only took a photo of someone else's laptop where the sticker was. I couldn't find it online. If anyone knows where I can get the sticker, please tell me. Yeah, that's pretty much all I had to talk to you about. And there's one more thing I really want to shill, because we're all standing on the shoulders of giants. And in Fediman's case, it's DPC who couldn't be here, unfortunately. He's based in the US, so it's a long trip. But he is building this really awesome GitHub project called Rust Shop, which is basically a blueprint for how you would set up a new company that totally is based on Rust, on Nix, on all these great things. He recently released something called Flakebox, where you can set up your whole build environment in a flakified way. Definitely check it out. It's an awesome like repository of his ideas and like just general best practices on how to use Nix. And yeah, he has introduced a lot of the great stuff we're using today in Fediment. So big shout out to him. And yeah, that's why you should use Nix. And you can find my slides here. If we have time for any questions, I'm happy to answer them.
Anyone? Any questions?
How do I work for Fediment? You use Nix a lot, right? So how do I work for Fediment? Because it seems like a great place.
I mean, just join the project. It's an open source project. Come and join us. Oh.
Yeah, I can add a couple things. So you guys can go to https clover.app/instance/Fediment, and that will spin up it'll spin up a VPS with the Nix Docker image, and it'll run Nix develop and have VS Code on there. And so it'll spin up just in your browser a VS Code attached to a VPS running our Fediment Nix Flake, right? And so that's the fastest way to get started on developing on the project. And then tomorrow, because DPC can't be here, I'm going to go through his workshop of how to do Flakebox, right? And so that's all of our Rust tooling and Nix tooling that he pulled out, and just like so we're just going to like make a new like cargo new, and then just flakify it, and then start adding some like complex dependencies and stuff to it. And we do, for Fediment, we do developer calls on Mondays at, 4 p.m. UTC, right?
I think it's like 6 Central European time, so probably 4 UTC.
Yeah, it's 9 a.m. Pacific time. I know that. Right. Yeah, so we do that on Mondays, and then Thursdays we do that, and we normally do deep dives on Thursdays, and the last like 3 weeks of deep dives have just been on like Nix Flakes, right? And so it's like an hour with like guys like Eric, DPC, guys who like know what they're doing. And so definitely come to those.
Cool. Thanks, Eric.
Awesome. Thank you.